那我也挺想对吧？没有你去老师说
国家的
我是不想真好。不谢了。
Anyone else, guys? Did you guys done question 1 yet? Not yet. All right. Let me show you how to. If you haven't done it already, let me show you how to. This is question 1, guys. So you have three observations: x1, x2, x3, IID, normal with parameters mu and sigma squared, and you have 2 estimators for mu. The first one is sorry guys, can you see this from over there? You can't? Come on guys. Anyway, I will write here and put it here, okay? Is that okay? I will continue writing here, then after I finish writing I will put it here. Okay? I'm sorry, I don't know what else I can do, guys. I mean, all right, the first, maybe it's too bright. Is it too bright or what? Is it too bright? Do you know where the lights are? Where the lights are? Is it better now?
Oh shit.
Okay. Okay. All right guys, so you have 2 estimators for mu 1 hat and mu 2 hat, right? Now the question, listen guys, the question is which one of them is better and why? So remember, there are 2 criteria. One is bias, the other one is MSC. So I'm going to compute the bias first. The bias of remember, the bias is the expectation minus the population parameter, which is this, right? Which is the expectation of yes, and this is quarter yes, quarter times the expectation of x1 is mu plus 2 mu plus mu minus mu, which is 0. So the bias of the first estimator is equal to 0. Now let's see the second estimator. Okay, it's equal to this by definition, and this is equal to the expectation of equal to this, and this is equal to a third times the expectation of x1, the expectation of x2 plus the expectation of x3, right, minus mu. This is a third times mu plus mu plus mu, right, minus mu, and this is equal to 0. So in terms of bias, listen guys, in terms of bias, there is nothing to distinguish between the 2 estimators, because both estimators have bias equal to 0, right? So they perform equally well with respect to bias. So the next thing we're going to do, I'm going to put this over here, guys. Hopefully the guys over there can see it better now. All right. Now the next thing I'm going to do is to find the MSC of the 2 estimators. All right. to find the MSC of mu1 hat, right? Remember, because mu1 hat has bias equal to 0, this is equal to this. Equal to this, yeah. And this is, now when you pull out the 4 outside, it becomes 16 times the variance of x1 plus 4 times the variance of x2 plus the variance of x3. Yes? Now we know that each xi has variance sigma squared. So this is 16th times sigma squared plus 4 sigma squared plus sigma squared. So this is basically 3 sigma squared divided by 8. Okay? So this is the MSC of mu1 hat. Similarly, the MSC of mu2 hat Are you listening, guys? The MSC of mu2 hat is the variance of mu2 hat, and is the variance of x1 plus x2 plus x3 divided by 3. Yeah, now taking the 3 outside, it becomes a 9, right, times the variance of x1 plus the variance of x2 plus the variance of x3. Okay, so it's the 9th. Each of these has variance sigma squared, so it's sigma squared plus sigma squared plus sigma squared. So this is sigma squared by 3. Now let me ask you now. We have the first estimator has MSC equal to 3 sigma squared by 8. The second estimator has MSC equal to sigma squared by 3. Now which one of this is smaller? Because yes? It's the second one, obviously, right? Clearly, sigma squared by 3 is smaller than 3h squared by 8. All right? So mu all right, so that completes. Is that clear, guys, or not? So the mu2 hat is the vector of the two estimators. All right, so can you do question 2 now, please? Yeah, it's going around somewhere. I don't know where. Can you pass it on? They're the same.
The same.
They're the same. Yeah. Can I do it? You sign something? Yeah. Okay. Anybody else who hasn't signed the attendance sheet? How do you get 0 to x? everybody sign this guy. Can you do question 2, guys, now, please? Yeah, AID means independence, identical independence. Yeah, some of them are on the website. Yeah, not all the answers, but I think most of them are. Most of the answers are on the website. Yes, yeah, on the web page, of course. If you go to that, I'll show you where it is. Can you go to? I'll show you where it is. Sorry, yeah, hey. She got to the sorry, just a minute. Sorry, guys. Well, up. See, some random questions with solutions. So just click on it. Yeah, that contains a lot of solutions. Yeah. All right, guys. Can you now listen to question 2? So I know many of you have done. All right, guys. Could you please listen to? You have xi IID with normal distribution, and you have an estimator for mu, which is of this form. An estimator estimator for mu, right? And we want the first part of the question is to show that this estimator is unbiased, right? To show that something is unbiased, you need to find, I mean, I already said this thousands of times already, hundreds of times, I mean. I have already, so in order to show that this is unbiased, you need to find the bias, okay, which is the expectation of minus mu, right? This is mu, guys, mu. Okay. Now this becomes, if you take the expectation inside, it becomes this, right? Now we know that the expectation of xi is what? Is mu. So this is the sum yeah. Now because mu is a constant, you can pull it outside the summation sign, so it becomes mu times the sum of ai minus mu. Now if you factor out mu, then you get, this is sum of ai minus 1, right? Are you guys with me so far? Yeah. And this is equal to 0. This is equal to 0 if and only if the sum of ai is equal to 1. Right, so that completes part 1 of question 2, right? So that the estimator is unbiased if and only if the sum of ai is equal to 1. So let me put this over here, guys, so you can see it better maybe. I mean the guys over there can see it better. Can you see it now? Okay. Sorry guys if I took it too soon. Alright, now part 2. Part 2 is to find the variance of the same estimator. So we want to find the variance of this estimator, which if you take the variance inside, it becomes the sum yeah. Now the variance of xi, what's that? The variance of xi is equal to sigma squared. Okay. Now because sigma squared is a constant, you can pull it outside the summation sign. So this becomes sigma squared times the sum of 1 to n of ai squared. Right? You're with me so far, guys? Right, now in the next step, I'm going to use the hint. You should look at the question, guys, in front of you. If you look at the question, guys, it gives you a hint. By the I know you are supposed to prove the hint, but I mean, just assume for the sake of, I don't have the time to prove it today, but just assume the hint, okay, without proving it, okay? By the hint, you can write the sum of ai squared in this form. Now, listen, guys. Now we want to minimize this quantity with respect to ai. The only term here that involves ai is what? This is the only term. This guy here is the only term that involves ai. 1 over n is a constant. It's a constant. It doesn't involve ai. This is the only term that involves ai. And this term here is a sum of squares of numbers. So what's the lowest? Do you understand my question, guys? What you have here is a sum of squares of numbers. So what's the smallest value you can take? 0, exactly. Yeah, so the smallest possible value you can take is equal to 0. And when will it be equal to 0? It will be equal to 0 if and only if and only if this term here, ai minus 1 over n squared, is equal to 0 for every I. Alright? So in other words, ai minus 1 over n is equal to 0 for every I. In other words, ai is equal to 1 over n for every I. Hence, the variance is minimized if ai is equal to 1 over n for every I. Is that clear, guys? That's what you were asked to show, guys. You were asked to show that the variance. Your answer? Yeah. Okay. The variance gets the smallest possible value when ai is equal to 1 over n. And thus, is that not clear, or are you sure? You okay? Clear? You just shout at me if it's not clear. I'll try to help you. Your answer, is that clear to you? You can't see. Maybe I'll put it over here, guys. Maybe you can see. Can you see better now? Are you guys okay with this? Do you want me to go through it again? No? You sure? Yeah. Can you do the next question then, guys? Question 3. You do question 3 please now. Try to use the hint, alright, for question 3. It's a hint also for question 3. Yeah, you can use it, but I don't know whether it will work here or not. I think this approach I given you is simpler. It's I don't know, maybe you're right, I don't know. Yeah, there are many ways of doing any question here. Yeah, you can do it in different ways. Yeah. Yeah. Can you do question 3, guys? Please. You all right, sir? Do you have any questions?
No.
You have a question?
No, I'm gonna finish.
Oh, okay, finished. Okay.
이거 전체적으로 허황해가지고 화도를 사는데 뭔가 생각보다
No, you don't need to know. Oh, you don't need to prove it, yes. Yeah. But you can prove it. Yeah, yes, you don't need to prove it. You know the Haskell distribution? Yeah. It has the Haskell distribution with n-1 degree of freedom. Yeah. You can use the property to prove question 3. It's on page, if you look at page 16 of the notes, yes. 1 to 6. Okay, you haven't covered it yet, but you can cover it too. 16, yeah. If you look at page 16, this is Haskell distribution. Haskell distribution, right? And one property is that if X has this density, then the expectation is equal to mu. Mu is the degree of freedom. Yeah, mu is the degree of freedom. So the expectation of a Haskell variable with mu degree of freedom is equal to mu. So you can use this property to do this question. I'll do it in a minute when it's good. Yeah, mu is just the parameter mu is not as the degree of freedom. All right, guys. Let me show. Some people are struggling with question 3. So you have xi and you have s squared defined like are you listening? If you haven't done question, I know many of you have already done question 3. So just look at this if you haven't done it. Okay. So this is a possible estimator for s squared. The first part of the question is to find the expected value of s squared. Now I'm going to use the hint, guys. The hint says the following. The hint says that this guy here has a chi-square distribution with n minus 1 degree. So I have introduced this factor n minus 1 and this factor sigma squared. So I need to reciprocate. So I need to divide by the same factor and multiply by the same factor. Do you see what I've done? I have multiplied by n minus 1 and divided by n minus 1, divided by sigma squared and multiplied by sigma squared. So I haven't changed anything. Yeah. So I'm gonna pull this factor outside the expectation. So this becomes this, yeah, and this is sigma squared by n minus 1. Now using the hint, according to the hint that this has a chi-square distribution with n minus 1 degree of freedom. Now if you look at page 16, I know we haven't come to this stage yet, but if you look at page 16 of the notes, right? If you look at page 16 of the lecture notes, you will see that one of the properties I have given you is that the expected value of something like this is equal to n minus 1. All right? That's on page 16 of the lecture notes. So this guy here cancels out with this guy, so you get sigma expectation equal to sigma squared, and therefore s squared is unbiased for sigma squared. Do you guys follow this or not? Yeah? Yes? So this is how you do the first part of the question, right? To prove that s squared is unbiased, just simply use the hint. It is fairly straightforward. I mean, it's not really hard. You should do it, otherwise it will be really long, because this way is really short. Okay. Right, now to do the second part of the same question, let me put it over here, guys. Hopefully you can see this better. To do the second part, we need to compute the variance, because remember, if an estimator is unbiased, then the MSE is the same as the variance. So the variance of s squared, right? I'm gonna apply the same trick, guys. I'm gonna write the variance of s squared as like this. All right. So you see what I've done. I have multiplied by n minus 1, divided by n minus 1, divided by sigma squared, and multiplied by sigma squared. So I'm going to put this in brackets and take this outside. So it becomes okay. See, when you take a constant outside, you need to square it. I'm sure you know this. Yeah. Now, by the hint, this is equal. This is a chi-squared variable with n minus 1 degree of freedom. Now, if you look at page, I know we haven't come across this yet, but if you look at page 17 of the notes, if you look at page 17 of the lecture notes, you will see that this guy here is 2 times n minus 1. Right? And therefore, what you have is 2 sigma 4 divided by n minus 1. And this guy here approaches 0 as n goes to infinity. Alright, and hence S squared is unbiased. S squared is unbiased and consistent. Yeah. Is that clear, guys, or not? So by using the pen makes things easy. Right, to do calculations. Yeah? Can you do the next question, please? Question 4. Just one more question. How are you? Okay. You guys okay? Are you okay with that? Is that okay? Yeah, that's good. Yeah, hi. Yeah, but I would do them during the lecture. The other questions for which you can't find the solution. Like today I did, like you were in the lecture, today I did 10 and 11. I did question 10 and question 11 in the lecture. So likewise, I will do this one, this one, this one. This one is already there. Yeah, but the solution is online. Yeah, for this one. You should look the link I showed you. Yeah, the solution for this is the link. Yeah. Yeah, look again. I'm sorry. But I will do this one later, not today, but maybe some of the week I will do it later. I will do most of them, like by the end of this course, I will do most of the questions. Yeah. No, they're not home. But if you can do them by yourself, that will go through. So that way you develop confidence, in problem solving. Yeah. And if you have problems like doing any question, just come and see me in my office. You guys done question 4? If you haven't done it, let me show you how to start. Okay, so this is question Q4. Right now, the first you're given an estimator for gamma, which is this guy here. All right. Now the first part is to show that the gamma hat is an unbiased estimator. So you need to show that the bias of gamma hat is equal to 0. Right? That's what you need to show. Right? So this guy is the expectation of gamma hat minus gamma. This is the expectation of 1/2n times the sum of xi squared minus gamma. So this is 2n here. So it's 1/2n times the sum of the expectation of xi squared minus gamma. So this is 1/2n times the sum. Now the expectation of xi squared, to find that, you need to, just like I did in the lectures this afternoon, right? To find this guy here, you need to integrate from 0 to infinity of x squared times the density function, which is right. Are you with me, guys? Now to do this integration, some of you say this is a complicated, but it's not really complicated integral, guys. It's not really difficult to integrate. What you need to do is you just need to do a substitution, or I just suggest you something here, guys. What you need to do is you just substitute y equal to x squared by 2 gamma. So this implies that x is square root of 2 gamma times y. Alright? So dx by dy will be gamma divided by 2. Yeah. Now if you sub this into this and simplify, you will get the answer you need. All right. I will leave this at this point. Right. You know what to do. Rest. Right. I'm sure you guys know integration better than me. So just make the substitution, simplify the integral, and use the definition of the gamma function, which I talked about in the lectures last week, right? And eventually you will get the value that should reduce to 0, right? All right, guys. If you have problems, come and see me, guys. So I'll see you guys tomorrow in the lectures from 12 to 1. As I said, I will start on a new topic, which is maximum likelihood estimation. Right? All right.
Yeah. 这个老师他就是智障。我说这老师就是智障，你说你是他不是他？这你说这你妈，我这还有比你，我这还来比你，你看我哪看？就开玩笑的是吧？你生气了？我真生气了。 就说这个numerical analysis 方式。这三个是因为咱是不是这样对自己的做的对手？因为咱是不会这样对自己的。
我刚拿的真的吗？就是3斤。
是，回家都有做。你看，好像跟输的水平回家都一样。不管了，你想不啊？你想不会吧？不是，我来给你设计一个稳赚不赔的 portfolio， 怎么样？
你从哪门课最后上出来是那个
？contingency， 这都是真他妈都是奇迹，一个他妈的人品对证明无限制。
保佑我contingency也没做事情。
上回家，上来要是那边带了有2个不好。
其实没有，我上台在他家学习。回来我上来跟你吃饭嘛，然后我就跟他说你在我家楼下吃饭。操，他妈什么人啊？这家伙，我操！哎，他交了房费吗？你们可以看。
是啊。
我不知道，我每次跟你交那么多钱，他就花完了都不知道花哪去。
我被堵在这里，冯女士，你让我。
你往这边走啊！你果然智商加1000。
你看你这个人的素质。
我是这个啊！
你好像把这个会对对呀。哦，确实是我的。
这是你的智障。这个什么素质？
你这不是我的。